So the HondaJet is a carbon fiber fuselage empennage aircraft. The wing is metallic, and on the fuselage they're using expanded metal foil. I believe it's copper. I worked on that program, but I believe it's copper. And so when you have smaller private jets, so sort of Part 23 light jets, I'll call them, the composite structure is not thick. It's not like a 787 where it's a quarter-inch thick. It's much thinner than that. So the lightning protection is really critical. And in the HondaJet case where they're using an expanded metal foil, one of the critical factors is how much paint you apply on top of that foil. So part of the lightning qualification process is to go off and to test that carbon fiber part with the copper foil with a certain amount of paint on it. You always use a worst case paint because as you get thicker in paint, the expanded metal foil becomes less effective and you start to have punctures or damage into the carbon fiber structure. So in the Honda case, it's a very aerodynamic aircraft. It's a very advanced aircraft, and they did a lot of honing on reducing weight in that aircraft to make it efficient. And it's one of the most efficient light jets on the market, and maybe the most efficient light jet on the market right now. And so they're having a lot of sales because it just doesn't have the fuel burn that other aircraft do. And so part of that deal is that you have to be able to control the paint thickness. Now, HondaJet early on, and a lot of aircraft companies started out by just having painters, hand guys in masks and the whole thing with sprayers, spray paint on it, and try to keep it within that certain thickness range. So typically, an aircraft specs will say that the paint thickness is somewhere around 5 mils thick, so 5/1000ths of an inch thick is where the paint is. But that's hard to do on a large object, particularly if there's contours on it. So the paint thickness varies a good bit. And I've worked on programs like that in composite programs where the paint thickness was, plus or minus 3-4 mils. It depends. Mostly plus, very little on the minus side. It's like +4 and -1. So in the case of Honda, and they're having so much expertise on building of cars and painting of cars for that matter, and have done it for a number of years, they have used robots to do it. And so they decided to take the technology from the automotive sector, which they are great at, and apply some of that knowledge into the aircraft market. And they started painting their aircraft with robots. And it was brilliant. And there's a YouTube video of it now, and you can just go watch this process happen. But essentially putting on the white top coat paint, which is usually the problem child, is that white top coat trying to control its paint thickness. Well, they can get very, very consistent paint thicknesses because they're doing it automatically, which is brilliant, right? So not only can they have a very lightweight structure and they're using a very advanced expanded metal foil for lightning protection, but they can also do the other thing, which is to control the paint thickness coming out of the factory. That's genius, right? And that's where a lot of other aircraft programs have struggled, quite honestly, is controlling paint thickness, because as employees come in and out, and as techniques change, and one guy does it one way and another painter paints it the other way, you get wide variations, and it just adds a lot of labor and time and cost into the product. Well, Honda has just eliminated that. They've eliminated all the variability, and they've done it robotically. That is absolute genius, and the aerospace industry should have done it years and years ago. The military has done it on some of their applications. The U.S. military has done it on some applications. I believe some of the European forces have done something similar, but you don't really see it in the commercial market. Honda's done it, and it's amazing to watch. You should go watch that YouTube video because it's amazing to see that go on.